Okay, welcome back to math class and welcome to 10-4, inscribed angles. So an inscribed angle basically happens when you've got your circle and you have an angle whose vertex is on the outside of the circle and its sides continue inside the circle. Its sides are basically chords inside the circle. This angle is an inscribed angle. What's important to note here with this inscribed angle is the arc that's formed by these two chords is called the intercepted arc. Intercepted. So this is an inscribed angle, this whole angle, and the arc that's made by the opening of the angle is the intercepted arc. What's important to note about how these two things are related is basically the measurement of this angle, the inscribed angle, is half the measurement of the arc angle, the intercepted arc angle. So hopefully you guys remember from previous sections how we find the arc angle is going from the center point of my circle, I kind of missed, to these points, and finding that angle. That'll give us the angle of the whole arc. So basically what I'm saying is the measure of angle 1 equals 1/2 the measure of angle 2 here. Now there are a couple of ways that we can use that, but basically what you'll see is something like, here, this one is x, find x if this angle is 70. So if I know that angle 1 is half of angle 2, basically x equals 1/2 times 70, which is 35. Now you might see it written like this. You might also see it written with 70 degrees on the outside. It's still labeling this arc, this degrees. You still use the number even if it's there. These are just two different ways it could be written, because they may not draw this angle at all. They'll just give you this one and tell you that this arc is 70 degrees. What they're telling you when they say that the arc is 70 degrees is that that angle is 70. Hopefully that makes sense. The next thing I want to talk about is if we have an inscribed angle, let's just use this one. So we found out that this one was 35. Now, I found 35 by saying 1/2 of the arc length. So it stands to reason if I had another inscribed angle in this circle, but its endpoints of its chords were the same, so say it starts here, but it goes to the same 2 points. Maybe I should use a different color so it's a little more clear. I have a second inscribed angle, but it goes to the same 2 points. Now I found this angle by saying 1/2 of this, so I'm going to find this angle by saying 1/2 of this. So they're going to be the same. So anytime I have two inscribed angles with the same arc length, the angles will also be congruent. And the opposite is true as well. If I have two inscribed angles with the same angle measurement, that means they're going to have the same arc length as well. One other thing that we can do with this information is, suppose you had a triangle inside a circle, and instead of just an inscribed angle, I have an inscribed triangle. If one side of that triangle is the diameter of the circle, that means that its opposite angle is 90 degrees. Now we'll see how that's true, because if one side of the triangle is the diameter of the circle, that means it's cutting our circle in half. So what we know about this arc length here is that it's half the degrees of the circle. We already know a whole circle is 360 degrees, so half the circle is going to be 180 degrees. And this angle is half of the arc angle, so it's always 90. So anytime you see an inscribed triangle and one of its sides cuts through the diameter of the circle, through the center point, the opposite angle is 90 degrees. One last thing, that's with an inscribed triangle. With an inscribed quadrilateral, so we have quadrilateral, remember, is a shape with 4 sides. What we're gonna know about this quadrilateral, because it's inscribed, is that its opposite angles are supplementary. So if I label these 1, 2, 3, 4, I'm saying 1 and 3, the measure of angle 1 plus the measure of angle 3 are supplementary, which you guys should remember is 180 degrees. And opposite angles again, measure of angle 2 plus the measure of angle 4 are also 180 degrees. That's basically all you need to know for this lesson. You'll see several different derivatives of inscribed triangles and quadrilaterals, but if you apply these rules, you should be fine. Note that opposite angles of a diameter in an inscribed triangle is 90, and opposite angles in a inscribed quadrilateral are supplementary.